Hi, this is elevator pitch for Group 28 with the paper titled Win with What You Have QoS-Consistent Edge Services with Unreliable and Dynamic Resources. Let us start with understanding what is edge services. Edge services are the services delivered from the resources located closer to the end user, but these resources are mobile and have less energy reliability compared to the cloud services. Thus, we require mechanisms that can dynamically adapt to the available computing resources, network conditions, and user requirements. So, the previous work called as MOLE introduced a concept of equivalent microservices that can be performed sequentially or parallelly to maintain quality of service. Here we can see an example of traffic management where we have three different microservices to accomplish this task. That is to use a motion sensor or use a surveillance cameras or use a GPS tracking using mobiles. And using these three microservices, we can have a execution strategy, like in which order we have to execute these microservices. And Mole itself has two predefined strategies, execution strategies named as failover strategy and a speculative parallel strategy. Failover means that sequentially execute the services. When one fails, the backup service is called, and the parallel execution means all the services are performed simultaneously and stops when one of them succeeds. To create consistent QoS in dissimilar edge environments, the paper proposed uh, approach. The proposed approach has four parts. One is to estimate QoS attributes. The QoS attributes considered are cost, latency, and reliability. In order to estimate the cost and latency, we construct a tree structure of execution strategies. And for reliability, we calculate the probability of successful execution of microservices. The second one is system design. The client sends a service request to Edge Gateway. Each service request has unique service ID. The Edge Gateway gets a service script from the cloud, which comprises of list of equivalent microservices and QoS requirements. Then Edge Gateway uses the feedback loop for dynamically generating the execution strategies. The third one is utility index. And the paper proposes a new metric called as utility index to evaluate whether a strategy is viable or not. In the equation, you can see the right side part is when a strategy satisfies the QoS requirements. The left side part is when it doesn't satisfy the QoS requirements, hence attaching a penalty K whenever it doesn't satisfy. And the next is strategy generation. If the number of microservices are below a certain threshold, we use a exhaustive search. Else we use a approximation algorithm. The approximation algorithm takes an input of equivalent microservices and sorts the microservices with their utility and outputs an execution strategy with the maximum utility. And the major enhancements over the mole are to use a feedback loop to adjust resource changes, and also generating a strategy locally at the edge gateway. Generating locally indeed justifies the title with win with what you have. So here, when we come to the results, we can see the number of QoS satisfied services are much higher compared to the predefined strategies. In fact, QoS satisfied services increases approximately by 2.6 times, and our proposed approach also has higher utility values compared to predefined strategies, which means most of the strategies generated exceeds the QoS requirement specified. In order to prove the major claim of the paper, that is the system self-adapts in case of resource changes, the experiment emulates the resource changes and uses feedback loop, and our system uses feedback loop to quickly adapt to the resource change, hence generating a new strategy to cope up with the resource changes, hence maintaining the consistent QoS. We observed from our side, we observed a weakness. That is, in the experiments, the paper doesn't consider the other QoS attributes such as bandwidth and power consumption, which may lead to challenging trade-offs such as increased bandwidth for low latency. And one of the future goals can be to improve the capability of microservices to handle multiple concurrent requests, which can improve the elasticity of the edge services. That's all we have. Thank you.